Okay, folks, so today we're going to talk about non-binary nomenclature. And if you remember from yesterday, binary meant two, so this means not two. So let's put our EQ in. It's the exact same EQ from yesterday, but we're just going to change the topic. So how do I write names and formulas for non-binary ionic compounds? All right. So as I just said, non-binary simply means not two, or simply two or more elements involved. And this is where we had a little conversation about a brand new vocabulary word. And that word is polyatomic ions. Whoo! Let's break it down. Well, we know what an ion is. An ion is a charged particle. We know that it can be either positive or negative. Okay? Positives are called cations, negatives are called anions. Okay? And if we're looking really carefully, we see the word atom. Boop. And then this word right here, poly. The word poly means many. So a polyatomic ion is a charged particle made of many atoms. Okay? Grab your pink chart real quick. On your pink chart, find this little thing. It's next to the electromagnetic spectrum. It's kind of sideways on your pink chart. These are all of the polyatomic ions that you need to know. We're going to add one, and it goes with the -2s. So grab a Sharpie. We're going to have CO2 is carbonite. Okay, carbonite. So if you look at all of these, we have POs and BOs and ASOs are always 3-. Okay, so you have PO3, that's phosphite, PO4, phosphate, BO3, borate, ASO3, arsenite, ASO4, arsenate. Those all have a 3- charge. Okay? Then you have your sulfates, your sulfites, your oxalates, your carbonates, your chromates, your dichromates, and your carbonite. Those are 2-. All the other ones over here have a -1 charge. Okay? So this big group over here, nitrates and nitrites, acetates, hydrogen sulfates, hydrogen sulfites, hydrogen carbonates, perchlorates, chlorates, chlorites, hypochlorites, permanganates, all -1. And then we have a little box over here of weirdos that don't fit into those categories. You have ammonium, NH4, that's 1+. You have hydrogen phosphite, which is HPO3 2-. You've got peroxides, which is an O2 2-, and then a hydrogen phosphate that's HPO4 2-. Okay? This chart right here, you'll have on a test, but this is the polyatomic ions chart. So you're going to need this to do all of these non-binary nomenclatures. Okay? So let's chat. So to write the name, you write the name of the metal, just like before. Okay? However, there is one cation that's a polyatomic ion. So here we're going to add or ammonium if you have NH4. Okay? So there is one positively charged cation that's a polyatomic. It's ammonium. It's NH4 1+. That's the only time it's not going to be the metal. So you're either going to say name of the metal or you're going to say ammonium if you have the NH4. Okay? Step 2, you're going to write the name of the polyatomic. And this is as simple as looking the name up on your polyatomic ion chart. Just be very careful because there are some that are very similar. There's an SO3 and an SO4. Those are very different and they have different names, but the only thing that's different is a single letter. SO3 is sulfite with an I, SO4 is sulfate with an A. So be very careful that you make sure you write the correct ending. Okay? Huge important thing. Yesterday I said you change the ending to IDE. That's when you have a nonmetal, not a polyatomic ion. So you do not change the ending. The only exception to this is if the polyatomic ion that you have is ammonium and then you just have a nonmetal. If all you have is the nonmetal, then you're gonna change the ending to IDE. But if you're writing a polyatomic as in the nonmetal spot, you don't change the ending, you don't change anything. All right, so let's talk formulas. Formulas is a little, let's do some examples of that real quick. Just kidding. So a couple of examples of writing the names for this. Let's say I had Na2SO4. Okay, so the first thing we kind of want to do is we want to kind of split off the metal from the polyatomic. So I'm just going to kind of, boop, there you go. So we have sodium, that's my metal, SO4 is my polyatomic. So the name of Na is sodium, so we write the name of the metal. And then I'm going to go to my polyatomic ions chart. SO4, that's sulfate, ATE. So we're going to call this sodium sulfate. Sodium sulfate. Boop. Okay, let's try one with an ammonium in it. So let's say we had NH4, 2, oxide. So ammonium oxide. So we write the name of ammonium. Now this time we don't have a polyatomic over here, we just have a nonmetal because the polyatomic was in the front. It's here. So this time we are going to go oxide, change to IDE. Okay, like we did before. All right. Let's talk formulas. So to write the formula, number 1, write the symbol for the cation, which is going to be the metal or ammonium. Okay? Number 2, write the symbol for the anion, which is usually going to be your polyatomic, or it could be a nonmetal. Put the polyatomic, whatever polyatomic you have, whether it's ammonium or it's one on the end, it's an anion, you're going to put it in parentheses. Okay? And then step 4, crisscross and reduce if needed. So same as yesterday, the only difference is the polyatomic goes in parentheses before we do the crisscross. All right, so let's try one of these. Let's do magnesium chloride. Okay, so we know magnesium is an element, so let's just put the symbol for magnesium. And then let's go to our polyatomic ions chart. Sorry, it's back a ways. Chlorite. Watch that ending. It was an ITE. It's over here. That's going to be ClO2, and the charge is 1 minus. Okay, and I'm going to notate that it's a 1 minus up here. All right, we're going to put our polyatomic in parentheses. The charge on magnesium, he's a group 2 metal, so that's going to be 2 plus. So I'm going to take the 2 from the magnesium, and it goes down, doop, there. The 1 from the chloride would go to the magnesium, but we don't write ones. So this would simply be MgClO22, magnesium chloride. Okay? Let's do another one. Let's do one we have to reduce. Okay? So let's say we have aluminum phosphate. Okay? Aluminum we know is a metal, so that's going to be Al, and it has a charge of 3 plus. Phosphate, At, I'm not going to go back to the polyatomic ions chart because it's so far behind us. But if you look at your polyatomic ions chart, phosphate is PO4, and it has a 3 minus charge. All right, we're going to put our polyatomic in parentheses. We're going to take the 3 from aluminum, give it to the phosphate, 3 from phosphate, give it to the aluminum, but both of those are divisible by 3. And when we do that, they cancel out. So this would just be AlPO4. Now, if we didn't end up adding any numbers, what we will usually do is take the parentheses off the polyatomic and just leave it as AlPO4. And there doesn't actually need to be a space between them. So if I was going to write this on my worksheet, I would probably do it more like this. Boom. Done. Okay, let's try one last one with ammonium at the front. All right, so let's say we have ammonium chloride. Now, little hint, this is an IDE. None of your polyatomics end in IDE except for peroxide and cyanide. So if it says IDE, that means we're talking about chlorine, the element. Okay? And then ammonium, if you look at your polyatomics chart, that is NH4, and it has a 1 plus charge. Chlorine is group 17, so that has a 1 minus charge. So when we crisscross that, the one would go there, the one would go there, we don't write ones, so it would just be NH4Cl. All right? So that, ladies and gentlemen, is non-binary ionic nomenclature. We're going to spend tomorrow practicing that.